Okay, what I'd like to do is number 6, problem number 6 from the last minimum skills. That would be semester 2, letter C. What we've got is we've got a 500 kilogram roller coaster, and we want to find the velocity at point C. So I want to find velocity here, and at point D, the velocity here. First thing we're going to do is we're going to keep track of all the energy transfers. So we're going to make our bar graphs for energy transfers. Initially at the top of the first hill, we said we would assume that velocity is 0 just as we go over the top of the hill. It goes very slow. We're going to assume it comes to a stop. So we've got no kinetic energy. There's no springs, no bungee cords, etc. So there's no elastic energy. In fact, I'm going to wipe it out from all of these because it's not going to be in there. I purposely didn't put E internal in any of these because we said that roller coasters, unless it specifically says that there's friction, we're going to assume that there is no friction. Here, there's nothing about friction, so we're going to assume that it's frictionless. So that means that at the top of the hill, all of our energy comes from gravitational. So all of it's gravitational. We get to the bottom of the hill here, C, it is no height above the ground, so all of that energy is kinetic. In D, we've got some gravitational and some kinetic because clearly roller coaster doesn't come to a stop. Could probably make a little more kinetic. Clearly roller coaster doesn't come to the stop in the middle of the ride. So at this point, there's still more ride left. This is going to continue on, and it is above the ground. So we've got both gravitational and kinetic. So let's go ahead and attack this one at a time. We'll find the velocity at C first. So for C, so we'll go at C. What we have is our gravitational from the beginning is equal to our kinetic at point C. So the next thing we'll do is we'll put in our equations. So we've got mgh is going to be equal to ek. I think I'm going to do this the slow route. So at the top of the first hill, we've got a mass of 500 kilograms is times g, which is 9.8 meters per second squared, times h, which is 35 meters. So I wind up with, whoa, let's move that over. There we go. Maybe shrink a bit, huh? Rats. Ah! There we go. There. All right, so I've got 500, turn it on, 500 times 9.8 times 35, and that's going to be equal to 171,500. 171,500. That's a kilogram, meter squared per second squared, which we said is a joule. So that's the energy at the beginning. That's going to be equal to Ek at point C. So that's going to be equal to 1/2 times the mass, which is 500 kilograms, times v squared. So that means that v squared is going to be equal to 1/2 times 500 is 250. So I'm going to divide that over to the other side. So I get v squared is equal to 171,500 divided by 250. And since we started with kilograms, joules, everything's going to come out just fine. We know this is going to be in meters squared per second, or excuse me, meters per second. So v squared is equal to this mess here. I'm going to square root both sides. So square root this side, square root this side to get a final answer of v is equal to So that's 171,500 divided by 250. Enter that's 686, and I want to square root that. So second square root, second answer, 26.2 meters per second. So that's at point C. At point D, what we've got is we've again got that energy gravitational that we started with. Is going to be equal to energy gravitational at point D plus the energy kinetic at point D. So we already know that that energy at the beginning, this gravitational, was 171,500 joules is going to be equal to mgh at point D plus 1/2 mv squared at point D. So I'm going to have 171,500 is equal to the mass is 500 times g, which is 9.8, times h, which is 21 meters here, plus 1/2 times 500 v squared. So I'm going to have 171,500 is equal to, let's go ahead and figure that out. Got 500 times 9.8 times 21. Hit enter. We get 102,900. So it's 102,900 plus 1/2 times 500. You know what? Let's just go ahead and figure that out. That's 250. 1/2 times 500 is going to be 250 v squared. So now all I have to do is solve for v squared. I'm going to subtract the 102,900 over to the other side. So we get plus that one. Yeah, there we go. 171,500, 68,600. So I get 68,000, 68,600, right? Yes. 68,600 is going to be equal to 250 v squared. So v is going to be equal to, I divide both sides by 250 and square root both sides. I get square root of 68,600 divided by 250. So v is going to be equal to, so I got 68,600. I'm going to divide that by 250. Hit enter, and then I'm going to take the square root of that, so second square root, second my answer, and hit enter, and I get 16.6. 16.6 meters per second is my velocity at point D, and I'm done. Really, what we have to remember is whatever energy I start with, that's going to be the same energy that I have throughout. That's what we were doing with the bar graphs earlier, where we said, okay, if this is, 3 and this is split, fairly evenly, I'd go, half and half. This is, really roughly about 2/3. So this is about 1/3. This is going to be 2/3, and we're good. So there we go.